record, maximize, and then obviously I got to share. All right, so real quick. Last time we spoke, this is what we were talking about. Steps for solving. Oh, wait, is Tanisha here? Or Tanisha, I'm sorry, I said it wrong. I always say it wrong. Tanisha, oh, she's connecting the audio. Look at that. All right. So, Tanisha, did you get my email?
Yes, I did.
Did it make sense? Because I wrote a lot.
It was kind of late. I'm gonna go over it today.
All right.
Get off for class. I'm gonna look over it.
No problem, because we're gonna go over it again too. So that will just supplement what I'm going over today. But yeah, I wrote a lot. So I wrote like every little step down because you said you were like having issues with when to apply something.
Yeah, and I read it, and I actually understand. I think I'm just using more steps with certain problems.
Yeah, and that could be a thing. All right, so let's go over this then. So the last time we spoke, we were talking about solving equations that contain a fraction. And the only new step is this step right here, step number 1. That's the new one, which is if you see a fraction, multiply by a number that will eliminate all denominators. And that number has a special name. The name is the LCD. Okay, now I'm going to be honest with you. You don't necessarily have to find the LCD, but the LCD makes it easier. Almost any number will work provided it's a factor. I don't want to go too far down that road though. For now, I want us to find this LCD. Step 2, if you see parentheses, use your distributive property. Step 3, combine like terms on the left, combine like terms on the right. Step 4, get the variable terms on one side, constant terms on the opposite side. Step 5, look at the number in front of the variable, divide both sides by it, and then step 6 is the check. So we should all have these steps written down now. Because what I'm going to do is I'm going to go ahead and we're just going to finish what we started with solving equations. All right, so here's one right here. So x minus 1/12 equals 5 over 6. Now I'm going to say the steps out loud, but I'm not going to, what the hell, I'll just write it. Step 1. Oh, I don't like that marker. Way too thick. Step 1, fraction, or denominators. I'll just put denominators. All right. So I look at all my denominators. That x actually has a denominator. It's over 1. So my denominators are 1, 12, and 6. I want you to find the LCD between 12 and 6 because the 1 really doesn't even matter. To do that, we break down the prime factorizations. The LCD is going to have the multiplication of the different primes, and you want to look at the most, meaning inside that 12, you have 2 times 2 times 3. Well, that is the most number of 2's I see in any factorization. So my LCD is definitely going to be 2 times 2. Now the 3 you can take from either one, it doesn't matter, because I only have 1 3 in the 12 and 1 3 in the prime factorization of 6. So I'm only going to have 1 3 in my LCD. When I multiply all these together, 2 times 2 times 3, the answer is 12, and that is the number I'm going to multiply everything by. Now, excuse me, Tanisha over the weekend showed me something in the my math lab homework where what they say is multiply 12 by both sides. And here's how they write it, okay? So I'm going to write it up here, and it's not wrong. But what they're doing is they're multiplying 12 by both sides of the equation. And then they're saying, okay, now that you see parentheses, go ahead and distribute. All right. Now that's what the view and example looks like inside of my math lab. What I do is I don't write this right here. I don't write that at all. Because I know no matter what, I need to multiply 12 by every single term inside this problem. So what I do is I multiply 12 by x, 12 times 1/2, and 12 times 5 over 6. So I go directly into this spot right here. Okay? That's what I do. They just do one more additional step, which is they just put everything in parentheses and put 12 off front first. If you want to do that, fine. No matter what, you're going to have to do what I do, which is multiply every single term by 12. And by doing that, watch what happens, okay? Just give me 1 sec. So step 1, find an LCD, get your denominators, that's out of the way. Step 2, let's simplify a little bit. 12x stays the same, so I'm going to write this in black again. Go back to black. Minus. Now, this is the most important part, okay? The whole reason why you multiplied every single term by 12 is so you can do this. All eyeballs up on the screen real quick. All right? All eyeballs up on the screen. The whole reason why you chose 12 is so you can do this. They reduce. With whatever is left over in the numerator is exactly what you write. Okay? Now, on the right-hand side of the equal sign, you have 12 times 5 over 6. Now, what I was shown the other day is this. I'm going to rewrite the 12 as 2 times 6. The reason why I chose 2 times 6 is because I have a 6 as a denominator. And my goal is to do this. I just scratch them out. So now I've gotten rid of my denominator, and whatever is left over in the numerator is what I write. 2 times 5. Okay? Are there any questions with that step? Any questions? All right, good. So now I have 12x minus 1 equals 2 times 5, which is going to be 12x minus 1, and 2 times 5 is 10. So step 2 is done. Step 3, I look on the left. Can I combine anything? The answer is no. I look on the right. Can I combine anything? The answer is no. Step 4, I get the variable terms on one side, constant terms on the opposite side. So I need to add 1 to both sides. Now I have my variable term 12x on the left, and 10 plus 1 is 11, which is my constant term on the right. Step 5, I divide both sides by the number in front of the variable. Now, the 12 over 12 on the left-hand side, you can just scratch them out. You're left over with x equals 11 over 12. And that's your answer. So, by far, the most difficult step is step 1. It requires the most work. But once you get good at it, and you can start to see these things, okay, it gets very easy. But you got to practice it. That's all I can say. Are there any questions with that? All right. Let's look at the next example. So I have 1/2 minus 3 over 5 equals x over 10. Okay, now there are a couple ways that we can approach this, but I'm going to stick to my steps. So step 1, I look at all my denominators. Now, there is something that happens here, and it's very interesting. I want you to look at this number. Let me do that better. I want you to look at those two numbers right there, 2 and 5. What's 2 times 5? Can anybody tell me?
10.
And look at this denominator right here. What is that?
10.
So what do you think the number that I'm going to pick to multiply by everything to get rid of all my denominators? What number do you think I'm going to pick?
10.
Exactly. Does everybody see that? All right? Like, when you get good at this, you will start to see things like this. Even in the previous example. Look at the previous example. I had a denominator of a 1, which we don't really care about that. But I had a denominator of 12 and a 6. What number times 6 equals 12? 2. So you know that you can multiply everything by 12. So down to letter F, we're going to multiply everything by 10. So 10 times 1/2 minus 10 times 3 over 5 equals 10 times x over 10. All right? Now, we're going to simplify each denominator. And here is like the way to do this, all right? This is the easiest way. Before I was showing you how to break everything down. Excuse me. I want us to just watch the screen. Robert, can you help me? Can you unmute yourself real quick? You're going to help me. You ready? All right, here we go. I'm going to highlight what I'm asking you. What's 10 divided by 2? Good. What is 10 divided by 5? Good. And lastly, what is 10 divided by 10? Good. You can mute yourself now. Does everybody see what I just did? Does everybody see what I just did? Are there any questions with that? All right, because that's the way I'm going to start approaching all my problems. See, I was doing that before, but I was breaking it down for you. Now, what I'm going to tell you is this. The reason why we chose 10 is because we can divide 10 and that denominator, and it simplifies into a whole number, like 5 and like 2. It was easy for us. 5 times 1 is 5. 2 times 3 is 6. 1 times x is x. And I know 5 minus 6 is negative 1. Does that make sense, everyone?
Wait, so for the first one you did 2 times 5 and then the 5's crossed out.
No.
Or the 2's crossed out.
No. No, the first one I did, and I'm going to highlight again for you. I did 10 divided by 2. What is 10 divided by 2, Mike? 5. So I wrote a 5.
Okay, and then 10 divided by 5 is 2. Okay.
There you go. You take each one of them, okay? Good job, by the way. All right, next one. Actually, I think it's the last one, yep. 2/3 minus 1/4 equals x over 12. Look at your denominators, 3, 4, and 12. I'm going to multiply everything by what number? I think Leah said it. She was muted. 12. All right, so 12 times 2 over 3 minus 12 times 1 over 4 equals 12 times x over 12. Now, take each one of these things separately. So we know this is really 12 over 1. So the whole reason why you pick 12 is so you can do this move right here. What is 12 divided by 3? Somebody. 12 divided by 3 is? 4. Next one. 12 divided by 4 is 3. And then the last fraction. 12 divided by 12 is 1 times x. So now all you do is simplify. 4 times 2 is 8. 3 times 1 is 3. 1 times x is x. And 8 minus 3 is 5. Okay, are there any questions? Are there any questions with that? All right. So what we're going to do now is we're going to move into chapter 5. Okay? So, oh, I forgot to upload those notes for you. I can do that real quick. How did I forget to do that? What class is this? 01. Handouts. Lecture notes. Just give me 1 second here. I'm going to get all of our lecture notes for chapter 5. Well, not all of them, just the ones that we need today. All right, they're up. Now for us, I'm going to go ahead and import the first one. So can anybody, while I'm sitting here doing this, can anybody tell me what a decimal is by chance? I mean, we've heard of decimals before, but what exactly is a decimal? No clue?
It's a fraction, but it's not in fraction form.
Well, yeah, you know what? I like the way you said that. Decimals are like fractions in the sense that they represent part of a whole number. So, like, for example, if I got this little simple number line, okay, and I'm between 0 and 1, well, right in the middle we know is 1/2, but I could also write that as 0.5 or 5/10. Okay? So a decimal gives us numbers that are in between whole numbers. Okay? And all decimal numbers will always have 3 parts. They have a whole number, which is out front of the decimal. Then you have the actual decimal point itself. And then you have the decimal part at the very end. Okay? Now, decimals have place values, and they follow the whole number convention. It's just the only difference is there is a THS at the very end. So, like, for example, the number that I have there, 17.758, is actually read 17 and 758 thousandths. So notice I'm kind of overemphasizing the THS at the end, which I will do that for a while, only so you can hear it. So what I have here is a nice little picture. I took this directly from your book. All right. And here are the actual place values. So notice that you have the whole number part. That's the 17. Then you have the decimal point. A decimal point separates. Actually, let me use a different color here so you can actually see it. Because it's bolded in the picture, but I think it's better if you actually see the color. There we go. So that red line separates whole numbers from decimal parts. And if you go to the right, it's going to be the tenths, the hundreds, the thousandths, 10,000ths, 100,000ths, millionths, and so forth. So the first thing that we're going to learn how to do is we're going to learn how to read a decimal or write a decimal, okay? And it's actually very simple. There's only 3 parts to it. So step 1, you write the whole number part in words. Then you use and for the decimal point. And then lastly, you write the decimal part in words as if it was a whole number followed by the place value of the last digit. So let me show you how this works. I'll zoom out here so you can still see the picture. So for 0.06, the way that we actually write this and we read it is you write the whole number part in words. Well, we don't have a whole number here. So you would just leave it. You wouldn't write anything. The decimal, well, since we don't have a whole number, we don't have to worry about the word and. So we go directly into step 3, which is we're going to write 6 as if it was a whole number. But then the 6th is actually in the hundredths position. So you would just write 6 hundredths. And that's the first one. Okay? Are there any questions there? All right. For part B, I'm just going to scroll up a little bit. For part B, write the word negative. 200. So there's my whole number part. Now I got to worry about the decimal, so I put the word and. And now I write the decimal part as a whole number. $73. And now, all I have to do is just match up where that 3 is according to its place value. So remember, if you go to the right, it's going to be the 0 is in the tenths position. The 7 is in the hundredths position, which makes the 3 in the thousandths position. So this would be negative 273 thousandths. Okay? Now, go ahead and do the last one for me. Okay, what did you get? Did anybody get it yet? Anyone? All right, I'll wait another minute. Okay. Did anybody happen to get an answer yet?
829 million.
829. Now let's count out the places. So the 0, that's the tenths, hundreds, thousandths, 10,000ths. All right. So remember, Mike, it goes tens, hundreds, thousandths, 10,000ths, 100,000ths, and then millions. Okay? Yeah, don't worry. I made that mistake too the first time I did this.
I was gonna say 10,000, but it didn't sound right, so that's why.
Yeah, I'm with you. It's very wordy. Is that proper to say? It's very wordy.
Yeah, like.
I mean, we can actually measure things down to the 10,000th. We actually can measure things down to, I think down to the millionth. Like, pistons inside your car, I think, are measured down to the 10,000ths or 100,000ths. So when they build your car, they make sure it's that precise. It's amazing how precise, machinery can get. All right, are there any questions? Okay, so on the next page, we're going to write decimals in standard form now. So we're taking the words and we're just writing it out as a number. That's it. So the key here is when converting a decimal from words to decimal notation, you want to make sure that the last digit is in the correct place. And if you need to, you will insert zeros if necessary. So for example, the first one, 596 hundredths. Now, the 500 is my whole number. The and is my decimal. And then, and then the 96 hundredths, that's going to be my decimal part. All right? So I'm going to keep it nice and simple. 500. The and stands for my decimal, and then 96 hundredths. Now, I know this position would be my tenths. That position right there would be my hundredths. So since I only have 96, I would just write the numbers 96, and that's it. That is a little different than part E. So part E, I'm going to do the same thing. So 39, there's my whole number. The word and is my decimal. But now, the 42 thousandths, you got to be careful with it. A nice, easy technique is you start writing these little spaces like I do. This is the tenths, hundreds. Here's our thousandths. And since I only have two numbers, and I know the 2 is in the thousandths position, then I will write the 4-2, and I need to put a 0 there. And that's how I use the correct number or the correct place value, by inserting zeros if necessary. All right? Are there any questions with that? Like, I think objective 1, objective 2, pretty straightforward. In fact, objective 1, which is writing it out in words, I don't know how many people still write checks. You young people, do you write checks anymore?
No.
I write 15 checks a year. That's it. Taxes, and then when I donate money to my local church. That's it. And I just give them a check at the end of the month. So, yeah, and it's funny when you young people, have you ever wrote a check? I know you said you don't, but have you ever did it?
Yeah.
All right, so you've at least done it once. All right. Because I'm with you. I wish checks weren't a thing anymore. But like taxes, for example, like I gotta pay my municipality tax this week, and they want a check. They don't want cash, and I'm like, come on. But anyways, all right. Objective 3. This is a biggie. This is a biggie. Writing decimals as fractions. So there is a relationship here between decimals and fractions, and the way that we do this is, first, I give you the decimal. Second, you're going to write it out in words. And by writing it out in words, it actually tells you how to write the fraction. So, for example, with 0.07, now, I said that very generically, so I can show you how this works. 0.07 in words is 7 hundredths. Whatever the place value is, hundreds, thousands, 10,000s, that is always going to be your denominator. So 0.07 in words is 7 hundredths, and as a fraction, it's 7 over 100. Now, if that's the case, then the next one, 0.51, I would write this as 51 hundredths. And the fraction would be 51 over 100. Now, there is something that you always want to do. Remember, and this is the last sentence in the statement above. Remember, you always want to simplify any fraction. You always want to do that. Okay? All right? For the next one, 29.97. Well, that's going to be 29. And need to write a little clearer. 97 hundredths. All right? And we write that with the whole number first, 29, and then 97 over 100. Okay, are there any questions so far? Are there any questions so far? All right, let's keep going. Oh, misspelled. So this one's going to be 5 hundredths. Now this we need to be careful with, because I can totally simplify that fraction down to 1 over 20. So even though 0.05 is read 5 hundredths, as a fraction, it's 1 divided by 20, or 1 over 20. Okay? And then the last one, I tried to trip you up a little bit by putting a negative, but that's okay. We just write the word negative. 64 and 8/10 as a fraction. It's going to be negative 64 and 8/10. And we always want to just reduce the 8/10 as 4/5. So I think the most important part here is just to make sure the fraction's simplified. That's it. Okay? I feel like I'm moving fast. Are we okay? Are there any questions? Because I'm going to scroll all the way up now. Going once. Going twice. All right, sold. So, objective 4, comparing decimals. So we learned how to read them. We learned how to write them. We've learned how to convert them into decimals. Convert decimals into fractions. Now we're going to just go ahead and compare. So, real quick. To compare 2 or more positive decimals, compare the digits from left to right. All right? And then, when 2 digits are not equal, the number with the larger digit is considered to be the larger decimal. If necessary, maybe insert some zeros afterwards. You'll see. I'll give you an example of that. So let's go ahead. Let's just look at this. So for examples F and G, we want to insert the less than, greater than, or equal symbol to form a true statement. So here's how we do this. You start on the far left of the number, and I'm going to go ahead and just draw little arrows. And I compare 2 and 2, they're the same. Now I move to the right. 6 and 6, they're the same. So I move to the right. Now I'm in the decimal part. 2 and 2, they're the same. Move to the right. 0 and 8. Now they are different. So when I compare this, 0 is definitely smaller than 8. So 26.208 is less than 26.28. Let me write my less than symbol better. There we go. And that's how you compare decimals. You just go from left to right. So the next example here. 0 and 0, they're the same. 1 and 0, they are different. So you compare. 1 is definitely greater than 0. So this would get a greater than symbol. Okay, now here's a little helpful hint. All right, if you're trying or if you're having trouble comparing 2 negative decimals, try the following. Compare their absolute values. Then, to correctly compare the negative decimals, reverse the direction of the inequality symbol. So what they're saying here is this. Let me show you. Down below, we are going to compare negative 0.039 and negative 0.0309. What they're saying here is this. Write out the positive values and compare them. 0 and 0 are the same. 3 and 3 are the same. 9 and 0 are definitely different. I know 9 is greater than 0. Oops, I hate when that happens. So the 9 is definitely greater than 0. Now, this is their absolute values. So the answer is just going to be the opposite of that. So when I come back over to letter H, instead of putting a greater than symbol, I'm going to put a less than symbol. So negative 0.039 is less than negative 0.0309. All right? So let me walk you through that one more time, because it can be a little confusing at first. First, write out the positive values All right? So 0.039 and then 0.0309. I hate how they're so close. It's like a tongue twister to me. Anyways, just write out the positive values. Compare. This is the situation we ran into. So then, when I go back to the original problem, I just reverse the sign. So instead of it being, sorry, I had it backwards. So instead of it being greater than, it'll be less than for the final result. Okay? Now, if you are comparing, and I'm going to throw this in here. If you're comparing a negative decimal point or decimal to a positive decimal, I don't care how you look at this. There's only one right answer. There's only one way to do this. Negative numbers are always less than positive numbers because on a number line, they are to the left of 0. Okay? Are there any questions? All right. So the last thing we're going to do in this section is rounding. And we should have an idea of how to round. Remember, when you round, you locate the place value that you want to round, you draw an arrow to the right, and then you make your determination. If the number to the right is 5 or greater, you add 1 to the digit. So let me underline this. Actually, no, I'll highlight it. So if the number underlined is 5 or greater, you add 1 to the underlined place value and drop all the digits to the right. You just drop them. You don't write them. If that number is less than 5, the underlined place value stays the same. You drop all the digits to the right. So, with the very first one, 482 and what is that? 7,000 or no, wow, that's a crazy number. I'm not even going to read it. 482.7817. I get lazy when I read these. Other than if a question asks you how to write a decimal, I'll never ask you how to read it. Just read it like I do. 482.7817. All right? So here's how I do this. I'm going to write out the number. They want me to round to the nearest thousandth. So that position is occupied right there. The 1 is the thousandth. I look to the right. That number is greater than 5. So I increase the underlined place value by 1 and drop all the digits. So 482.782. So like I said, we should have an idea already on the process of rounding. It's just finding the place value, which is different here. Next example. Negative 32, what is that, thousandths? They want us to round to the nearest hundredth. So the 3 is in the hundredth position. I look to the right, that is a 2. So my underlying place value stays the same. And I drop all the digits to the right. So it's just negative 0.03 or negative 3 hundredths. All right. Now, to finish up this section, all right, we're just going to talk about a special number. And this special number is pi. All right. Now, pi is so special that it actually gets its own symbol. Not very numbers have that. So pi is approximately 3.141592658 And that number will keep going forever. It doesn't repeat. It's what we call an irrational number. All right? Now, this weird looking equal sign stands for approximately. Okay? And there is a relationship with pi and a circle. So I'm going to show you what this relationship is first, okay? So their circumference is nothing more than the outside distance of a circle. In other words, and I have this little paper towel right here. So if you look at this paper towel, notice it's a circle. But if I were to cut it right down here and fold it out, it becomes a line. So the circumference is nothing more than the distance around the circle. Okay? If I cut the circle in half, what we just found is the diameter. And circumference is equal to pi times its diameter. Now, here's the interesting thing about circles and pi. If I took this formula that I just gave you, C equals pi times D, and I divided both sides by D, what I can do is I can take any circle in the world and measure the circumference. And that's pretty easy. All you really need is just a piece of string and a ruler. What you do is you wrap the string around the circle, and then where the beginning of the string meets itself at the end, you just pinch it and then fold it out and use a ruler and just measure that. You found a circumference. You would put that number in the numerator. Then you can measure the diameter just by taking your ruler and measuring across the circle. If you divided those two numbers, you will always get 3.14159,265, and you can get more decimal places provided your measurements are better. That will always happen. It'll happen with the top of a cap. It'll happen with a tire. All right? It'll happen with a Cheerio. I like Cheerios. I eat Cheerios in the morning. All right? Always. You take the circumference divided by its diameter, and you will always get pi. And remember, like I said, pi is an irrational number, which means the decimal part never ends and never repeats. There are some people that take pride in memorizing like pi to 50 decimal places. Great. I think you've wasted time in your life. You could have been helping somebody instead of memorizing whatever. I don't like memorizing things. That's just me, though. All right, are there any questions? All right, so here's what we're going to do. It's 10:50. I don't want to start anything new because I'm not going to have enough